Hello everyone, good morning. So this is lecture number 6 of ordinary differential equation. So what we are doing in ODE is that we have been solving a solution of, we have been solving a differential equations of first order and first degree, right? So in the previous 5 classes, we have been solving differential equations of first order and first degree. The very first class itself, I have given you the syllabus of ODE, and then I have given you that there are many methods to solve a differential equations of first order and first degree, right? Um, First method is variable separable method. Second is equation reducible to variable separable method. And the third is homogeneous differential equation, right? So we have completed all these three. Now we are going to move on to the fourth method, which is equation reducible to homogeneous differential equation, right? So I'll just show you what we have did so far so that you will have more clarity, right? And if you haven't watched the previous classes, go through all the previous 5 videos. Then only you will have clarity of what we are doing, right? So I can see this is the PDF of the last class. In the very first class, I have given you that there are many methods to solve a differential equation of first order and first degree. We have completed the first three methods. Now we are going to move on to the fourth method, which is equation reducible to homogeneous, right? We have completed these three in the previous classes. Now we are going to solve a differential equations of first order and first degree such that the equations are reducible to homogeneous differential equations, right? So we'll start today's class. Voice is low. Okay, so I'll raise my voice. Okay. So I think you have clarity of what we are doing, right? So we'll start equation reducible to homogeneous differential equation. Equation reducible to homogeneous differential equations, right? So first I'll give the procedure of how to solve, right? How to identify whether that the equations are reducible to homogeneous differential equation, right? So first we will do the procedure. After that we will solve problem, right? Okay. So to solve dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. So whenever you have a differential equation of this form, it can be reduced to homogeneous differential equations, right? Ax plus by plus c divided by a dash x plus b dash y plus c dash. Here a, b, c, a dash, b dash, c dash are constants, right? So whenever you have dy by dx equal to ax plus by plus c divided by a dash x plus b dash y plus c dash, it can be reduced to homogeneous differential equations, right? Now we will have two cases. We are going to discuss about case 1 in this class, and then we're going to solve problems based on case 1 today. The next class we will be discussing about case 2. Right? So what is case 1 is case 1. So case 1 is when a by a dash, the ratio a by a dash is not equal to b by b dash. So whenever this happens, right, a by a dash is not equal to b by b dash means we need to solve under case 1, right? So in this entire class, we will be solving problems based on case 1 only, where the ratio a by a dash is not equal to b by b dash. If case 2 will be a by a dash is equal to b by b dash, right? So how to solve dy by dx equal to ax plus by plus c divided by a dash x plus b dash y plus c dash whenever a by a dash is not equal to b by b dash. So we know this can be reduced to homogeneous differential equation, right? Okay. So what you have to do is, I tell you the procedure. So put, right? So put small x is equal to capital X plus h. Put small y is equal to capital Y plus k, right? We have to use this substitution first. Listen this procedure carefully, and you can do problem very easily, right? Put small x equal to capital X plus h. Put small y is equal to capital Y plus k, where capital X and capital Y are new variables, and h and k are constants. And h and k are constant, right? Now, what about dx? It will be capital dx, right? It will be capital dx. And what about dy? It will be capital dy. I'm differentiating with respect to capital X, right? Differentiating with respect to capital X and capital Y. So dx by dy will be 1 plus 0, and dy by capital dy will be 1 plus 0, right? I'm differentiating with respect to, okay, I'll write you procedure. Differentiate with respect to capital, here I'm different with respect to capital X. So dx by capital dx equal to 1, and here I'm differentiating with respect to capital Y. So dy by capital dy is equal to 1. This implies dx is equal to capital dx, and dy is equal to capital dy, right? So what I'm going to do is, I'm going to substitute this dx, dy, small x, small y value in equation number 1, right? Now 1 becomes, this is the procedure, right? Now 1 becomes, so what is 1? So 1 is dy by dx is equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. Now substitute, now small, it will be capital dy, it will be capital dx, right? Because our small dx is capital dx. Now ax, now what is x? It is capital X plus h. B into capital Y is capital Y plus k plus c divided by a dash into capital X plus h, b dash into capital Y plus k plus c dash. Right? So we have dy divided by dx is equal to, so we will be having ax plus by plus some constant term, which is ah plus bk plus c divided by a dash x plus b dash y plus, we will collect all those constant term, right? I'm just grouping the variable. It will be a dash x, a dash h plus b dash k plus c dash, right? So as of now, we have using the substitution. Put small x is equal to capital X plus h, small y is equal to capital Y plus k, right? So very important. Now what we have to do is, we need to find the value of h and k, right? Because we don't know this h and k, right? H and k are constant. Now we need to find the value of h and k by solving these two equations, right? Now choose hk such that, choose h and k such that, right? We need to choose hk such that this equation has to be satisfied. That is ah plus bk, ah plus bk plus c equal to 0, and a dash h plus b dash k plus c dash is equal to 0, right? So solve for h and k, right? You need to solve for h and k, which you can do by elimination method, right? Because the c and c dash are constant, you just treat h and k as variable, you just solve for h and k, right? Because it's a, b, c are constant, right? Solve for h and k using elimination method or whatever method you know, cross multiplication method, elimination method, etc. Solve for h and k using elimination method. So from this you can find the value of h and k, right? From this you can find the value of h and k. To understand the procedure, problem solving is very easy. To solve for h and k using elimination method. Now this, let us call this as 2. Now 2 becomes capital dy by capital dx, capital dy by capital dx, capital dy by capital dx is equal to ax plus by divided by a dash x plus b dash. Now these two will become 0, right? Because we have substituted h and k, we are finding h and k such that this is 0, this is 0. So therefore 2 will become like this. Because we have found h and k such that these both are 0, right? Ah plus bk plus c is 0 and a dash h plus b dash k plus c dash is 0. Which is a homogeneous differential equation, yes or no? Which is, now you can see this is reduced to homogeneous differential equation, right? Which is a homogeneous differential equation in capital X and capital Y, right? So far here we have small d, small y, small x, but here we have capital X, capital Y. No problem, right? Now you have to follow the previous method of how to solve a differential equation, how to solve a homogeneous differential equation. What you will do? Put capital Y is equal to Vx, right? Usually we'll put small y to be equal to Vx. Here everything we will be having capital X, capital Y, right? Now you have to follow the same method as we did in the homogeneous differential equation. So differentiate with respect to capital X. So we will have dy by dx is equal to v plus capital X into dv by dx. Now substitute this y and dv by dx value. Let us call this as equation number 3. So substitute this dy by dx. Substitute dy by dx and capital Y value in equation number 3. So you know, right? From now on you can do. So what is capital dy by dx? V plus capital X into dv by dx is equal to a into x plus b into y is bx. Divided by a dash x plus b dash y x. So this x will get cancelled. Now you can see you will have what? Functions of b and dv to one side and dx by x other side, right? That it is reduced to homogeneous differential equation. Separate the variable and integrate to get the required solution. To get the required solution. The solution you will have capital X and capital Y, right? In the solution you will have capital X and capital Y. What you have to do? Replace small v to be equal to capital Y by X, and wherever you have capital X, you replace that by small x plus h. And wherever you have small capital Y, you replace by y and k, where h and k will take the value of this, right? Where let us call this a star, where h and k will take the value of the solution of star, right? Because when we are solving this, we can find h and k. So substitute h and k here and replace capital X to be small x plus h, capital Y to be small y plus k. That's it. This is the procedure. Is it clear? You understand the procedure? Problem solving is very, very easy. That is what I am saying, right? So whenever you have dy by dx equal to ax plus by plus c divided by a dash x plus b dash y plus c dash, this equation can be reduced to homogeneous differential equation. There are two cases. Case one is a by a dash is not equal to b by b dash. This class we are going to discuss only about case 1 and then we are going to do problems on case 1. So whenever we have a by a dash is not equal to b by b dash, you put small x to be equal to capital X plus h, small y to be equal to capital Y plus k. So therefore, your small dx will be capital dx, small dy will be capital dy. So substitute the small x, small y, dx, dy value in 1 and you will have ax plus by, a dash x plus b dash y and some constant ah plus bk plus c, here a dash h plus b dash k plus c dash. Now you need to solve for hk such that these two are 0. To solve for hk using elimination method. So these two are 0 now. So you will have only this part. Now you can see this is a homogeneous differential equation, right? You know what is meant by homogeneous differential equation from the previous class. Now you make use of the previous method. Is it clear? The procedure is clear. Can you move on to problem? Can you move on to problem? Right. So we need to solve this differential equation. Dy by dx equal to x plus 2y minus 3 divided by 2x plus y minus 3, right? Yes, okay. So we will solve this. Now we can see this is of the form ax plus by plus c divided by a dash x plus b dash y plus c dash. And you can see a by a dash, let's call this as 1 solution. So here a by a dash is not equal to b by b dash, right? Because 1 by 2 is not equal to 2 by 1, right? Because a is 1, a dash is 2, b is 2, b dash is 1. That means it falls under case 1, right? Falls under case 1. So what you have to do? So put small x to be equal to capital X plus h, small y to be equal to capital Y plus k, right? So therefore, your dx will be capital dx and dy will be capital dy. Right? Substitute in 1, so 1 becomes capital dy by capital dx is equal to x is capital X plus h plus 2 times small y is capital Y plus k minus 3 divided by 2 times capital X plus h plus y is capital Y plus k minus 3, right? So just put small x to be equal to capital X plus h, small y to be equal to capital Y plus k. So therefore, we will have capital dy by dx is equal to capital X plus 2y plus some constant term which is h plus 2k minus 3 divided by 2x plus y plus 2h k minus 3, right? This is what we are doing. This is what we'll do in procedure, right? So let us call this as equation. Now solve for h and k such that these two has to be 0, right? So h plus 2k minus 3 is equal to 0 and 2h plus k minus 3 is equal to 0. Let us solve this equation, right? So therefore, let us multiply this by 2. So we will have 2h plus 4k is equal to 6. 2h plus k is equal to 3. We will have 3k to be equal to 3. This implies k is equal to 1. So since h plus 2k is equal to 3, we will have h plus 2 into 1 is equal to 3 This implies h is equal to 1. That's it. So therefore we have found the value of h and k. Right? So these are very simple part. You just have to solve for hk. Right? You just have to solve for hk. So I'm just multiplying this equation by 2. Right? So just solving this equation, that's it. So we have found hk, right? So we have completed these steps. So after separating this, we have choose hk such that these two are 0. So in our problem, our h is 1, k is also 1. So therefore, now this 2 becomes, dy by dx is equal to x plus 2y divided by 2x plus y, right? 2x plus y. Which is homogeneous. Right? From the previous class itself, you know when it will be homogeneous, f of dx comma dy equal to t power n into f of x comma y, right? So both are homogeneous differential equations of homogeneous functions of degree 1, right? This also degree 1, this also degree 1. Okay. Now what we have to do, which is homogeneous, now you have to follow the previous method. Put capital Y to be equal to Vx. So differentiate with respect to x. So we will have dy dx is equal to v plus x into dv by dx. Let's call this as equation number 3. Substitute capital Y and dy by dx value in equation number 3. So we will have dy by dx is equal to x plus 2y divided by 2x plus y. So v plus x into dv by dx is equal to x plus 2 into y. So y is vx divided by 2x plus y. Right? Now this x will get cancelled. We take common. So we will have v plus x into dv by dx is equal to 1 plus 2v divided by 2 plus v. So v minus 1 plus 2v divided, you just have to separate the variable, right? Minus x into dv by dx. To cross multiply this, so we will have 2v plus v square minus 1 minus 2v divided by 2 plus v minus x into dv by dx. So this 2v will get cancelled. So v square minus 1 divided by 2 plus v is equal to minus x into dv by dx. Separate the variable. You will have 2 plus v divided by v square minus 1 is equal to minus dx by x, right? Variables are separated. Variables are separated. Right? Variables are separated. That's it, right? So from now on, you can do very easily. Two plus v divided by, okay, so v square minus 1 is equal to minus vx by. So I can also write this to be equal to, so to cancel this minus sign, I'll write 2 plus v divided by 1 minus v square equal to dx by x, right? So integrate this. So integration of v plus 2 divided by, can write 1 minus v square as 1 plus v into 1 minus v dv is equal to integration of dx by x. So let us call this as I1, I, and this is log x, plus we will add some constant c, right? This is a required solution. but we need to find the value of I. So to find I, so b plus 2 divided by 1 minus v, 1 plus v, which is a proper rational function, right? Degree of numerator is 1, degree of denominator is 2. So therefore, I can do partial fraction a by 1 minus b plus b by 1 plus v. Now find the value of a and b. So multiply by 1 minus b, 1 plus v throughout. So we will have b plus 2 is equal to a into 1 plus b, b into 1 minus b. So put b is equal to 1. So we will have 1 plus 2 is equal to a into 2. So therefore, you will have a to be equal to 3 by 2, right? A to be equal to 3 by 2. Put b is equal to minus 1. Minus 1 plus 2 is equal to a into 0, b into minus 2. 1 is equal to minus 2b. So put b to be equal to minus 1 by 2, right? A into 1 plus b, b into 1 minus b. If b is 1, 3 is equal to 2a. A will be 3 by 2. If b is minus 1, minus 1 plus 2 is 1. Minus 1 is 2b. B is minus 1 by 2. So therefore, b plus 2 divided by 1 minus b, 1 plus b will be a by 1 minus b plus b by 1 plus b. What is a? A is 3 by 2. So 3 by 2 into 1 minus b. B is minus 1 by 2 into 1 plus b, right? Okay, now integrate this. So integration of this value of I, right? Minus b by 1 plus b dv is equal to, so 3 by 2 integration of 1 minus b dv minus 1 by 2 integration of 1 plus b dv. So this will be 3 by 2 log 1 minus b. Actually, a minus is missing, right? So we will multiply by minus, right? Because f of b, f dash of b. So minus 3 by 2 minus 1 by b. This log 1 plus b. So minus 3 by 2 log minus 3 by 2 log 1 minus b minus 1 by 2 log 1 plus b. This is the value of I. Here any minus is missing. B plus 2 is equal to a into 1, b into 1 minus. Check the ones again. It is b plus 2, right? B plus 2 by 1 plus b, 1 minus b. A by 1 minus b, b by 1 plus b. Multiply by 1 minus b, 1. We will have b plus 2 is equal to a into 1 plus b into 1 minus b. So if we put b to be equal to 1, we'll have 2a is equal to b. A is 3 by 2. We put b to be equal to -1. Now -1 plus 2 is 2. -1 plus 2 is 1. So this will be 0. -1 minus minus b is equal to 1. Everything is correct, right? A is 3 by 2, b is minus by 2. Any mistake I have made? This b value is where I made mistake. B value is plus 1 by 2. We have to get b value to be equal to plus 1 by 2. I'm getting minus 1 by 2. I don't know where I made mistake. So 2 plus b plus 2 divided by okay, sorry. Here I made mistake, right? B is minus 1. This will be 1 minus half minus 1, which will be plus 2, right? Sorry. B is plus 1 by 2. 1. 1 minus half minus 1. We will have b to be equal to plus. Okay, so we will have minus 3 by 2. Minus 3 by 2 log 1 minus b plus 1 by 2 log 1 plus b. And we know log a minus log b is log a by b. You can also use that property. This can be written as 1 by 2 log 1 plus b minus 3 by 2 log 1 minus b by 2 log plus b. Let's take this 3 to here, right, so that I can take, because we know a power x is x log a. I take 1 by 2 outside. Log a minus log b is log a by b. Log of 1 plus b divided by 1 minus b whole cube. This is the value of I. So star becomes, so I is equal to log x plus c, right? Log x plus c is c. I, let us call this as log c. This will be log x plus log c. I is 1 by 2 log 1 plus b divided by 1 minus b whole cube. It will be log a plus log b is log cx. So multiply this 2 to that side. That's it, right? So replace b to be equal to capital Y by x. And what is capital Y? Capital Y is small y plus k. Capital X is small x plus h. And what is the value of k? It is 1. H is also equal to 1. That means you have to replace b to be equal to y by x, and wherever you have capital Y by capital X, replace this, right? You will get the required solution. That's it. Let us take this 2 to that side. We will have log of 1 plus b divided by 1 minus b whole cube is equal to log cx square, right? If you take this 2 to that side and bring 2 to the power, right? Bring 2 to power. Log will get cancelled. So 1 plus, what is b? It is capital Y by x. 1 minus capital Y by x whole cube cx square. So x plus y divided by, where you will have x cube, you will have x plus y divided by x. Here you will have x minus y whole cube divided by x cube is equal to c times x square. So bring this x cube to there. So you will have capital X plus y by x into x cube by capital X minus 5 whole cube is equal to cx square. So this x square, this x square will get cancelled. So you will have x plus y is equal to c into x minus y into x minus 5 whole cube, right? So replace this capital X to be equal to capital X to be equal to small x plus h, which is x plus 1. The capital Y to be equal to y plus k, which is y plus 1, will be x plus 1, y plus 1, plus 1 minus whole cube. So you will have x plus y plus 2 plus, sorry, x minus, sorry, capital X is x, wait a minute. Small x is capital X plus h, right? Actually, I made some mistake here. By substitution, small x is capital X plus h, right? Capital X will be small x minus h. Sorry, right? Actually, here we have capital X to be small x minus h, capital to be small y minus k, right? So capital X is small x minus h, capital Y is small y minus k, right? Sorry. So we know that small x is capital X plus h, implies capital X is x minus h, h is 1 in this case, and we know small y is capital Y plus k, which implies our capital Y will be small y minus k. So in our case, capital X is x minus 1, capital Y is small y minus x minus 1, y minus 1 whole cube. So we will have x plus y minus 2 is equal to c into minus 1, this minus 1 will get cancelled, minus y whole cube is the required solution. Right, so sorry, here I made some mistake here. So here capital X is small x minus h, right? Because we have capital X to be equal to small x minus h, capital Y to be equal to small y minus, right? That's it, right? This is the procedure to solve a problem whenever you have dy by dx equal to ax plus by plus c. See, I have replaced this by minus. I have multiplied this by minus and I have changed this to minus. Kiran Kumar. I have just multiplied by minus. So that this b square minus 1 will be changed to 1 minus b square. And I am cancelling to minus. Okay, is it clear? See, from now on you can do any problem, right? From now on you can do any problem. Procedure is same. We'll move on to second problem. dy by dx all dy by dx equal to y minus x plus 1 divided by y plus x minus 5. Right? So you can see this of the form ax plus by plus c. Right? So we'll do this very fast. So here a by a dash is not equal to b by b dash. Right? 1 by 1 is not equal to minus 1 by 1. So it falls under case 1. So put small x to be equal to capital X plus h, small y to be equal to capital Y plus k. Therefore, dx will be capital Dx, dy will be capital Dy. Let's call this as 1. Now 1 becomes dy by dx is equal to y minus x plus 1 divided by y plus x minus 5. So this will be capital Dy by capital Dx. Y is capital Y plus k, capital X plus h plus 1 divided by capital Y plus k plus capital X plus h minus. So we will have dy by dx to be equal to y minus x plus k plus a minus h plus 1 divided by, here we will have y plus x plus k plus h minus 5. Let's call this as 2. Now we need to solve for hk. Now solve for h and k such that k minus h has to be equal to minus 1. That is, this has to be 0, right? Such that k minus h plus 1 is equal to 0. K plus h minus 5 is equal to 0, right? Now solve for hk. So we will have k minus h to be equal to minus 1. K plus h to be equal to 5. We will have 2k to be equal to 4. We will have k to be equal to 2. And since k minus h is minus 1, so 2 minus h is minus 1. So minus h is minus 2. So h is 3. So we have k to be equal to 2, h to be equal to 3. Now 2 becomes, we have capital dy by dx is equal to capital Y minus x divided by capital Y plus x, which is homogeneous. This homogeneous differential equations, because it is of the form dy by dx is equal to f1 of x comma y by f2 of x comma y. Now put capital Y to be equal to vx, differentiate with respect to capital X. We will have dy by dx is equal to v plus x into dv by dx. Let's call this as 3. Now 3 becomes, we have dy by dx is equal to y minus x divided by y plus x. So what about dy by dx? It is v plus, this substitute in 3, right? Substitute the value of capital Y and dy by dx in 3. So we will have v plus into dv by dx. Y is dx, dx minus x divided by dx plus x. So this x will get cancelled. So you will have v plus x into dv by dx is equal to v minus 1 by v plus 1. v minus 1 by v plus 1 is equal to minus x into dv by dx. To cross multiply this, you will have v square plus v minus v plus 1 divided by v plus 1 is equal to minus x into dv by dx. These two will get cancelled. Separate the variable. Here you will have v square plus 1 divided by b plus 1 equal to minus x into dv by dx. So we will have b plus 1 by b square plus 1 dv minus dx by x, right? Separating the variables are separated. Variables are separated. So integrate this. So integration of b plus 1 divided by b square plus 1 dv minus integration of dx by x, right? Minus integration of dx by x. So I can write this as integration of b by b square plus 1, integration of 1 by b square plus 1. This is minus log x. What we will do is we will multiply and divide by 2 so that this will be log b square plus 1, right? It will be 1 by 2 log of b square plus 1. So we know that integration of f of b by f dash of b, right? Sorry, f of b f dash of b is equal to log of f of b, right? So f of b f dash of b, log of f of b, and 1 by a square plus x square. This is tan inverse of b, right? Tan inverse of is equal to minus log x. So we'll add some constants, right? So 1 by 2 log b square plus 1, 1 by 2. Okay, this is the required answer, right? You just have to replace small v to be equal to what? What is small v? It is capital Y by x. Capital Y by x. So this will be 1 by 2 log of v square. So y square by x square plus tan inverse of y by x is equal to minus log x plus c. Now replace. Now what is capital Y? It is small y minus k, right? Sorry. Very beginning I have put a plus. Sorry. Capital Y is what? Small y minus k. Capital X is small x minus h. In our problem, our k is 2, and our capital X is small x minus h. Our capital X will be, and what is our value of h? H is 3. Now replace this is the required solution, because everything you have to have in small x and small y, but here we have in capital X and capital Y. So just put this to be equal to y minus 2, x minus 3, y minus 2, x minus 3. It will be x minus 3. That is the required solution. Is it clear? Very easy, right? So whenever you have dy by dx equal to ax plus by plus c, you have to follow this method, right? Very, very simple problems. Any doubt? On the third problem. So solve dy by dx is equal to x minus y plus 1 divided by plus y minus 2. So it is of the form ax plus by plus c. So it can be reduced to homogeneous differential equations, right? All are very easy problem. I'll do another 1 to 2 problem. Then I'll give you some exercise problem. I'll give you some exercise problem, right? Okay, so we'll solve this. Let's call this equation number 1. So here a by a dash is not equal to b by b dash, right? Because 1 by 1 is not equal to minus 1 by 1. Therefore, this comes under case 1. So put small x to be equal to capital X plus H, small y to be equal to y plus k. Therefore, your dx will be dx, dy will be capital D capital Y. Therefore, 1 becomes, so 1 is dy by dx is equal to x minus y plus 1 divided by x plus y minus 2. So we will be having this to be equal to dy by dx is capital X plus H minus capital Y minus k plus 1 divided by capital X plus H capital Y plus k. We will have dy by dx is equal to x minus y. Constants are h plus k plus 1 divided by will be x plus y. Constants are h plus k minus 2, right? H plus k plus 1, h plus k minus. Now solve for h and k such that h plus k plus 1 is 0 and h plus k minus 2 is 0. It is solve for this. To solve this, so we will have h plus k to be equal to minus 1, h plus k to be equal to 2, multiply by minus h plus h minus 1. And this is plus k, right? Plus k, sorry. So you will have this to be equal to minus 1. Capital X is capital X plus H, capital small y is capital Y plus k. So this will be x minus y minus x minus k plus 1. Now solve for this. So you will have h minus k to be equal to minus 1, h plus k to be equal to 2. So these two will get cancelled. So you will have 2h to be equal to 1. H is 1 by 2. Now since h minus k is minus 1 and h is 1 by 2, now minus 1. So we will have k to be equal to 3 by 2. So we have found h and k such that h minus k plus 1 is 0 and h plus k minus 2 is 0. Now 2 becomes capital dy by dx is equal to minus y divided by x plus y. This is homogeneous, right? Because we have substituted s to be equal to 1 by 2, k to be equal to 3 by 2 here, so that these two are 0, right? So now put capital Y is equal to Vx. Therefore, dy by dx is equal to v plus x into dv by dx. Let's call this as 3. Substitute capital Y and dy by dx value in equation number 3. So dy by so we have dy by dx is equal to x minus y divided by x plus y, right? X minus y divided by x plus y. So dy by dx is v plus x into dv by dx and y is bx. So this x will get cancelled. And so we will have v plus x into dv by dx is equal to 1 minus v by 1 plus v. So v minus v by 1 plus v is equal to minus x into dv by dx. So cross multiply this. So we will have v plus b square, right? E plus b square minus 1 plus 1 plus b divided by 1 plus b is equal to minus x into dv by dx. So we will be having b square plus 2b minus 1 divided by 1 plus b is equal to minus x into dv by dx. Separate the variables. So you will have 1 plus b divided by b square plus 2b minus 1 dv is equal to minus dx by x, right? Variables are separated. Now integrate this. Integration of plus b divided by b. Integration of x by. You can see if I differentiate this, you will have 2b plus 2. So here 2 is missing. So we will multiply and divide by 2. Right, this is log of b square plus 2b minus 1 is minus log x, right? That's it. This is a required solution. So we'll add some constant c, or we'll add some constant log c, right? Now you can do very easily, right? Log, this is log c by x, this is log. You can do from now on, you can do. Now replace b to be equal to y by x. Replace b to be equal to capital Y by x. And what is capital X? It is x minus h. And capital Y is y minus k. The h is, now the problem or h is 1 by 2. K is 3 by 2. So you have to replace capital X by x minus by 2, capital Y by small y minus by 2. Simplify, you will get the answer. Right? Simplify, you will get the answer. After simplification, you will have the solution to be y square plus 2xy minus x square minus 2x minus 4y is equal to some constant c. This is a new constant. Let's call it as some c1. This is the required solution. Very simple problem. Do one more problem and then I'll give you some exercise problem. Solve dy by dx is equal to minus of 12x plus 21y minus 9 divided by 47x 40y. Let's call this as equation number 1. So you can do any problem from now on, right? Because you know how to do problems based on variable separable method, and you know how to do problems based on homogeneous differential equation. So here a by a dash not equal to b by b dash, right? Here we will have 12 by 47 is not equal to 21 by 40. If we take this minus inside, Therefore, this is a homogeneous, this comes under case 1, which can be reduced to homogeneous differential equation. We have to use some substitution, right? We have to use some substitution. So put small x to be equal to capital X plus h, small y to be equal to capital Y plus k. Therefore, dx will be capital Dx, dy will be capital Dy. So 1 becomes dy by dx is equal to minus of, minus is common, right? Equal of plus h p1 y plus k minus 9 divided by 47 h 40 plus k plus 7. So we will have dy by dx to be equal to minus of, have 12x plus 21y 12h plus 21k minus 9 divided by 47x 40y 47h plus 40k plus 7. Now solve for h and k using a cross multiplication or elimination method. Solve for, and you can also use matrix method, inversion method also, right? Anything you can do. Very elementary. Solve for hk such that 12h plus 21k minus 9 0, 47h plus 40k plus 7 is 0. Solve for h and k. You will get s to be equal to minus 1, k to be equal to 1, right? You just do this, right? Very elementary. Solve for h and k using elimination or cross multiplication method. You will get this to be equal to s to be equal to minus 1, k to be equal to 1, right? 47. Okay. So therefore, this is, just call this as 2. Now 2 becomes, now 2 becomes have dy by dx is equal to minus of 12x plus 21y divided by 47x plus 40y, now which is homogeneous. So put capital Y to be equal to Vx, differentiate with respect to x, have dy by dx is equal to v plus x into dv by dx. Let's call this as 3. 3 becomes, now put dy by dx and y value in 3. So v plus x into dv by dx minus of 12x plus 21y. So y is bx. 47x plus 40y, y is bx. This x will get cancelled. So you will have v plus x into dv by dx is equal to minus of 12 plus 21b divided by 47 plus 40b. 47 plus 40b. Bring this term that side. So b plus 12 plus 21b by 47 40b to minus x into dv by dx. Now simplify this. So you'll have 47b plus 40b square plus 21 plus 21b. So you will have this term to be equal to or else you can also bring this b to that side, right? No problem. Okay, so after simplification, after separating the variable, you will have, right? I'll tell you the solution directly. After separating the variable, you will have 40v plus 47 divided by by 40v square plus 68b plus 12 is equal to minus dx by it minus dx by. So it's very simple, right? Here you will have 47 plus 40v. So after you are separating the variable, this will be turned to numerator. Here 47b, 47b plus 21b is 68b. Here you will have 40v square, and here you will have 12 is a constant, right? Now into d. Now you can see the variables are separated. Now we can integrate, right? Now we can integrate. Here 4 is common also. You can take 4 common here. If you take 4 common here, we'll have 40v plus 47 divided by, if you take 4 common, 10v square plus 17v plus 3 is equal to minus 2 dx by. I'm just taking 4 common and taking to this side. Integrate. Integration of 40v plus 47 divided by 10v square 15v plus 3 to minus 4 into log x plus all this to be log c. Now we have to integrate this. B minus, let's call this as I. So we need to find the value of I. To find I, we have to integrate this term, right? So 40v plus 47 divided by v square plus. So just do partial fraction. So just to factorize this, right? 10v square plus 17v plus 3. So if you do factorization, you will have 2v plus 3. Very elementary, right? 2v plus 3 into 5v plus 1. So sum is 17. Product is 30, right? Sum is 17, product is 30. Right? So it is not possible to factorize. Okay, you go for the quadratic formula, minus b plus r minus root of b square minus 4ac by 2a. After that, you find the two roots, and if x is equal to a is a root, x minus a is a factor, and if x is equal to b is a root, x minus b is a factor, right? So you write like this. Now this is a by 2v plus 3, b by 5v plus 1. Multiply throughout by this, so we will have 40v plus 47 is equal to a into 5v plus 1, b into 2v plus 3. Now substitute the value of, you will get the roots to be equal to minus 1 by 5 and minus 3 by 2. Solve this. Okay, now solve for, now put b to be equal to minus 1 by 5. Very simple, right? Put b to be equal to minus 1 by 5. Put b to be equal to minus 1 by 5. And b to be equal to minus 3 by 2, right? 2b is equal to minus 3. You will get the value of a and b. So you will have a to be equal to 2, b to be equal to 15. So therefore, this will become integration of 40v plus 47 divided by 10b square plus 17b plus 3 dv is equal to integration of, so a is 2, so 2 by 2v plus 3, b is 15, 15 by 5v plus v dv, right? Now integrate this, so f of v, f dash of v, this log 2v plus 3, and here 5 is missing, right? So what we will do is, we will write this 15 as 3 into 5, and f of v, f dash of v, so we will take this 3 outside, this log of 5v plus 1, that's it, right? This is the value of I, so 2v. Now from now on you can do, right? So substitute I value star and replace b to be equal to capital Y by x, and capital Y value is small y minus k, and in our problem our k is 1. I put capital X to be equal to small x h. In our value our h is minus 1, so this will be x plus. To do this you will get the required answer. After simplification you will get the answer to be equal to 3x plus 2y. Okay, I'll do this, right? So substitute in star, so this will be I is equal to, from star we have I is equal to log of, I can write this as x power 4, right? Minus log of x power 4 plus log c. So I value is log 2v plus 3. So log a plus log b will be log of 2v plus 3 into 5v plus 1 whole cube. Right, I'm just taking this 3 to that side. Log a plus log b is log ab. This will be log a by b will be log a minus log b is log a by b. Log will get cancelled. So we will have 2v plus 3 into 5v plus 1 whole cube is equal to c by, sorry, this is capital X. Right? Okay. So replace b to be equal to y by x, 2y x plus 3, iy by x plus whole cube, c by x power 4. So capital Y is 5 minus 1. Capital X is x plus 1. Right, c by x plus 1 whole square. If we cross multiply this, so we will have 2 into y minus 1, 3 into x plus 1 divided by x plus 1. Here we will have 5 into y minus 1 to x plus 1 divided by x plus 1 whole cube, c by x plus 1 whole power 4. Now we can see this x plus 1 whole cube, x plus 1 whole power 4, all will get cancelled. Right, all will get cancelled. So we will have 3x plus cube. Yes, that's it, right? So simplify this. So you will have 3x plus 2y, 3x plus 2y minus 2 plus 3. Minus 2 plus 3 is 1. Here you will have x plus 5y minus 5 plus 1 is minus 4 is equal to c. It is the required solution. So it stop here. So that's it. We completed the case 1, right? We completed. If you want, I'll give you some exercise problem in Telegram group. If you haven't joined Telegram group, the description I'll give you the link for Telegram group. So go through that. So what we did is, even though it is not homogeneous differential equation, it can equations of the form ax plus by plus c divided by a dash x plus b dash y plus c dash can be reduced to homogeneous differential equation. Case 1 is a by a dash is not equal to b by b dash. So whenever if this happens, you put small x to be equal to capital X plus h, small y to be equal to capital Y plus k. So therefore dx will be capital Dx, dy will be capital Dy. After that, substitute back here. Now you need to find the value of hk such that these two are 0. This entire term will become 0 now. So you will have only ax plus by divided by a dash x plus b dash y. Now which is a homogeneous differential equations. Now put capital Y is equal to small b capital X. Differential with respect to x, which is reduced to the previous method, right? So we have solved 4 problems, very simple problem. Next class we will be moving on to case 2, where a by a dash is equal to b by b dash. If this happens, what is the procedure? And we will do some problems based on that. Okay? So if you have any doubt, you can ask, or else we will wind up. Any doubt? If you are comfortable in previous classes means, if you have watched all the previous videos means, all these problems are very easy. You just have to identify what method we need to do, right? Okay, thank you all. I'll give some exercise problem for this based on this on Telegram group, right? Okay, I'll give you some exercise problem from here itself. So practice these problems, right? Give some exercise problem now. So we have 3 problems here. So solve the following differential equation. So you can see all these are based on the form ax plus by plus c divided by, that is dy by dx equal to ax plus by plus c divided by a dash x plus b dash y plus c dash. This is a solution for first problem. So practice this. So you can see we have dy by, first equation is dy by dx equal to this, right? 2x minus 5. This, so here a by a dash is not equal to b by b dash. So put small x to be equal to capital X plus h, small y to be equal to capital Y plus k. Right? You can do in your itself, right? So integrate this, you can see f of b, f dash of b. So log formula. So replace b by capital Y by x. And here you are getting h to be equal to minus 1 by 3, k to be equal to 1 by 3. Right? So practice this problem. This is the solution for first problem. And I'll give the solution for second problem also. Second and third problem also. This is a solution for a second problem. So given the question is 3y minus 7x minus 3 dx is equal to 7y minus 3x minus 1. So put this capital X and capital Y, right? Solve for hk. You'll get x to be equal to 0, k to be equal to 1. Right? Integrate this, do partial fraction a by b plus 1, b by b minus 1. You'll get a to be equal to 5, b to be equal to 2. And log of b plus 1, this is log of b minus 1. And replace b to be equal to capital Y by x. You'll get the solution for second problem. This problem 6, 7. Actually, I have solved 4 problems, right? Problem 5, 6, 7. It is 5th problem, 6th problem. Solution for 1, solution for 2, the solution for 3 also. It is solution for 3. Right? You just have to solve dA by dx equal to a by x not equal to b by b dash. Solve for hk, getting x to be equal to 1, k to be equal to 2. And again, you are getting this to be partial fraction. So do partial fraction a by 1 plus 2b, b by 2 minus b. You will get a and b to be equal to 1. And integrate, you'll get the answer. Right? That's it. So I have solved 4 problems and I've given you 3 problems for exercise. So all are very easy problems. Next class, we'll move on to case 2, where a by a dash will be equal to b by b dash. Right? Okay. So thank you. Practice these 3 problems along with these 4 problems. Right? Thank you.